I built a voice agent that can control a drawing canvas. It's built on top of tldraw and their agent starter kit, and it uses the OpenAI real-time model for the voice control. Let me show you a quick demo, and then I'll show you how it works and how to build one yourself. I'm going to demonstrate the voice agent with three different use cases. We'll start with two practical. First, a wireframe of a website I want to create, and then using the agent to create a PRD for a new feature that I need to develop. And then we'll wrap up with a fun game of tic tac toe with it. Let's jump in. First, let's have the voice agent create a wireframe for me.
Hello. Great to meet you. How can I help you today with your canvas?
Hey, I need you to wireframe a website for me.
Sure, I'd be happy to help with that. Let's start by figuring out what sections and elements you want on the site.
Yeah, I would like 3 pages, a homepage, a blog page, and then a page to show off kind of a portfolio of pictures from like my mountain activities.
I've set up the wireframes for the 3 pages: the homepage, the blog page, and the portfolio page. Each one has a clear layout with labeled sections. The homepage has a header, main content, and footer. The blog page has a header, 3 blog post previews, and a sidebar. And the portfolio page has a header, a 3x3 grid for your mountain photos, and a footer. Everything's neatly organized and ready for your next steps.
That's great. Could you remove the sidebar from the blog page and then have the blog post take up the full width?
The sidebar has been removed from the blog page, and now the blog post previews take up the full width.
Great. Could you add a footer on the blog page too?
The blog page now has a footer, consistent with the other pages. Everything is aligned nicely.
Thank you so much. The architecture of this agent experience is there is a voice agent that is using GPT Realtime, and that agent delegates to a more powerful Canvas agent that is built on Claude Sonnet 4.5, and that's the one that's actually manipulating the canvas. So when I'm having this conversation with the voice agent, I'm talking at a higher level, and then that agent delegates the heavy lifting to the Canvas agent that is built and provided in the tldraw agent starter kit. We can see that distinction in the UI in our sidebar. These blue messages are a transcription of the things that I say. The gray messages is a transcription of what the voice agent is saying. And then these different dropdowns with action and delegation is the interaction between the voice agent and the Canvas agent, and then the Canvas agent actually taking action. This accept and reject UI that you see here is a Canvas diff, where if we reject the change, that change just completely goes away, or if we click accept, it then is reapplied. This Canvas diff is really hard to build on your own, and it just comes for free in the agent starter kit. The last thing I want to call out is there is a list of to-dos here at the bottom. This is also part of the agent starter kit, and it is a way for the Canvas agent to keep track of what it is working on. For a second demo, we're going to have the voice agent create a technical diagram on the canvas for us.
Hello. It's great to connect with you. How can I assist you with your drawing or anything else today?
Can you help me diagram out this feature that I need to code soon? Maybe you could interview me to get some details.
Of course. Let's dive in. Can you give me a quick overview of the feature you're thinking about? What's the main goal or functionality it needs to have?
Well, the goal is to have a AI agent that I can text with my phone.
Got it. So the core idea is an AI agent that you can communicate with via text on your phone. Let's break it down a bit. What kinds of things do you want this AI to handle? For example, should it answer questions, manage tasks, or provide recommendations?
I think it should be able to answer questions and manage tasks. So I'd like it to be able to update my tasks, which will be in a database, and I'd also like it to pull from a knowledge base, which will just be like a collection of files.
That sounds great. So we have 2 main components. One is task management in a database, and the other is a knowledge base made up of files. Let's sketch out a high-level diagram. We can put the user interaction on one side and the AI agent in the center. Then we can show connections to the task database and the knowledge base. Does that structure make sense so far?
Yeah, that sounds great. Please proceed with the diagram.
The diagram is ready. We have a central AI agent connected to the user phone text on the left and branching out to both the task database and the knowledge base on the right. Each connection is clearly shown with arrows. It's laid out clearly and neatly.
Okay, and then, well, the user can't text the AI agent directly. We need to like include that as well in the diagram. So we should include SendGrid as our texting service, and that should then hit the backend, and that's what triggers the AI agent. But then the AI agent then responds through the backend to SendGrid to actually send the text message back to the user.
Great. The diagram now clearly shows the user messaging going through SendGrid, then to
Okay,
the
could
AI
you
agent.
fix, there's like some funky layout going on between SendGrid and the arrows. Could you take another look and just make that layout look better?
The layout has been corrected, and everything is now clean and balanced. The arrows show a clear, smooth flow from the user to SendGrid, then to the AI agent, and back.
Perfect. Thank you so much. What I want to call out with this one is the power of a voice experience over something like a canvas. Creating a diagram, even a simple one like this, could require a number of mouse clicks, but an agent controlling it is really powerful and removes a lot of the user friction. And then a voice agent controlling the canvas agent is even more powerful. I'm able to have this back and forth voice discussion where I have this voice agent actually asking me questions and helping me understand what I'm trying to diagram in the first place. And then the agent underneath, the canvas agent, is able to do the heavy lifting and actually create the diagram. For our last demo, let's play a game of Tic Tac Toe with the agent.
Hello. I'm here to help you with your canvas. What would you like to create or modify today?
Let's play a game of Tic Tac Toe. Could you start by creating the Tic Tac Toe board?
The Tic Tac Toe board is ready, with a 3x3 grid of equal squares. Now you can start your move. Who's going first?
Could you have me start first and I'll be X's? Could you put my first X in the top right?
I've placed your X in the top right cell of the board. It's your move now.
Sorry, it's actually your turn now. Could you place your circle somewhere?
I've placed my O in the center cell. Your move.
Okay, could you place my X in the bottom right now?
Your X is now in the bottom right cell. The game continues.
Okay, now your turn.
I've placed my O in the bottom left cell. Your turn.
Okay, could you put my X in the right center spot? And then I believe that's a win for me, so could you draw a big line connecting all of the X's?
You've won. I've placed your final X and drawn a big line through the winning combination in the right column. Congratulations.
All right, thank you so much. So the agent was maybe missing some tic-tac-toe knowledge, or it let me win. But here you can see the back and forth conversation, very rapid. I didn't have to put anything on the canvas, and I was able to draw all sorts of different shapes and then connect my winning right-hand column with a line. That was 3 different ways we can use a voice agent to control the tldraw canvas. Now, let me show you how I built this and how you can also build something similar. First up, let me show you how the agent starter kit works by itself. You can access it at tldraw.dev/starterkits/agent. The agent starter kit provides you this sidebar that allows you to control the agent. It's very cursor-like. I just provided a prompt asking it to create a mind map of the different coffee brew methods, and we can see that the agent was thinking for a while, and now it has started to take action on the canvas. We have this accept and reject canvas diff UX that I mentioned previously, and the agent keeps track of its to-dos here in the to-do list. At the bottom, we can see that we can select different models to use for the agent. We can add context for the agent. We can also stop the agent's interactions. So essentially, everything you need to create an agent to control the canvas is provided in this starter kit. So that's what the agent starter kit looks like, but how do we customize it and how do we layer in this voice functionality? Well, let's take a look at the front end first, and then we'll move to the back end. Here in my IDE, you can see a number of front end components here on the side. These are all provided in the agent starter kit. We had to customize the chat history a decent amount and also add in this voice call component. Everything else, this new chat button, the to-do list, and then the chat input that I have hidden right now are all included in the starter kit. The voice call component is what manages connecting to the real-time model. I'm going to walk you through the handle connect function because that is definitely where the rubber meets the road, the most complex part of this component. So we connect to the real-time model using a RTC connection. This is what allows it to be so fast. We can both interrupt the model and we can get the model responses back very quickly. For both recording our audio and then playing the agent's audio, we have to set up a few audio components. There's this audio element for playing the model's audio, and then also we have to get microphone access and record the user's audio. The next two listeners here are on this data channel. The data channel is how events are coming back from the model. This is how we get text and then display what the model is saying. And this is also how we get tool calls that then need to be handled, which we'll get into in a second. Further down in the function is how we actually create a connection. We are using the recommended OpenAI approach of this unified interface. It requires a SDP response, which is session description protocol. And it's essentially a handshake between our backend and OpenAI to agree on how the session is going to communicate. Our backend endpoint for creating that session looks like this. We receive the request from the front end. We set up this session configuration. Important here is we set the model that we want to use, either GPT Realtime or GPT Realtime Mini. We then set instructions for the agent. That's how we control the voice agent. And we also set tools for the agent and how those tools are used. We'll walk through both of those in more detail in a second. And we also add in this additional model for how we're going to do transcription. This is important because when you're using real-time models, they go audio to audio. If you want the text of what either the user or the model said, you need this transcription model as well. We then execute this handshake with OpenAI, return that response to the front end, and we're off to the races. We can customize the voice agent by setting its system prompt and also by providing it more or fewer tools. The system prompt that we have here is quite simple. We're just saying you're a voice agent on the tldraw canvas. For all the heavy lifting, use the delegate prompt tool. The delegate prompt tool then is also quite simple. We just say delegate prompt, use this to send canvas operations to the tldraw agent, and all you have to do is provide in a string of that prompt. When the voice agent needs to delegate to the lower level canvas agent, it will use a tool call. We capture that tool call here in our data channel listener. We wait for completed items, check if they're a tool call, and then we parse out the arguments and send them to this agent.prompt function. That agent.prompt function is provided again by tldraw. You can see it in this use tldraw agent. Here's a quick example of it. So we're just using that. We send the response, or we send the prompt to the agent, and then we capture the response a little bit further down, and we then send a new event in the data channel to say this was the response that we got from the agent. So we use the use tldraw hook, send that prompt to the agent, capture the response, send that back to the voice agent. That's the end of the voice agent customization that we added in. The rest of what I'm going to talk through is actually included in the agent starter kit, and this is what powers the Canvas agent. So the backend for the Canvas agent is a Cloudflare worker and durable object. Here are the entry points for the stream endpoint. This is what agent.prompt calls. Durable objects are really cool at Cloudflare primitive. They're essentially mini servers that can be spun up on demand. To create a durable object, we extend the base durable object class. We have a small router in here that collects the stream request and passes it to this.stream. This is this agent service. Clicking into agent service, this is kind of the core backend logic that powers the whole Canvas agent. We have some helper functions like getting model, or you can see here on the side, building messages, building response schema, building system prompt, and get model name. This all comes out of the box for you, so that way you can customize the agent or use different models across the big model providers. This stream function then gets model name, gets the model, and then essentially yields and iterates over stream actions and yields those events back to the front end. That's what allows the agent to have that interactive experience where the actions on the canvas are actually streamed one at a time. You don't have to just wait for the full answer, the full response to be completed. We get those incremental actions. In-stream actions is where we see the build messages and build system prompt functions get used. You can see those over here in the sidebar, and you can customize them however you would like. Next, we generate a stream of actions that are in kind of a custom data structure that get passed back to the front end. This is using stream text from the AI SDK, and there are a couple different provider options included in here as well. The rest of this function is some additional logic to ensure that each of the Canvas actions are formatted in a correct way. This is one of the most complicated parts about creating an agent that can interact on the canvas. You have all of these different types of actions. You can either draw lines, you could add shapes, you could add sticky notes, you can move objects, and each of those have a slightly unique data structure. And so this stream action function does a really nice job of collecting all of those available actions, putting them into a schema, ensuring that that schema doesn't break, and then yielding all of those events back to the front end so the front end can manipulate the canvas. And that's how we're able to create a voice agent that can control a tldraw canvas for us. We're able to use the OpenAI real-time model to delegate prompts down to a lower level agent that has full access and control of the canvas. That agent comes out of the box in the agent starter kit provided by tldraw. Thank you so much for watching. We're excited to see what you build next. You can learn more at tldraw.dev.